Within this chapter, we are going to discuss the business continuity aspects. What do you want to configure? What do you want to run in such a cluster? And we'll start with just looking at the nature of backup sites, of backup installations. What kind of backups do you have? We'll get to that during the backup chapter, like how to back up a full installation of Liferay anyways, but as I'm using the vocabulary backup, let me go in with my standard disclaimer. Nobody ever is interested in having a backup. That's a common wisdom, right? It sounds counterintuitive, but nobody wants to have a backup. Everybody wants to be able to restore to a new system. That's the business objectives. Backup is just a matter to get to the actual goal. You want to be able to restore somewhere else. So when we talk about backup sites, that's just something that is available for you to continue to run, to take up your load. And for that, well, in the classic business continuity world, we want to have an extra facility, means extra hardware, provide all of the reserve power that we need. In times of cloud, we'll have worldwide resources anywhere. So other people have enough computers so that we can just provision yet another one, yet another virtual machine. That's today's assumption. The connectivity, network infrastructure, server hardware just works if you run in the cloud. If you don't run in the cloud, well then, of course, make sure that you have these resources available. When we talk about the backup sites, we can talk about hot, warm, or cold sites. Hot sites would be quick to recover, but would have a higher maintenance cost. Why? Because you always have more servers than you need that can be cycled into production or that just serve your traffic anyways. If you always need 2 servers to serve your load and you're always running 6 of them, then, well, that's quite expensive, but they can easily, as they always run, they'll just take over the traffic anyways if 1 or 2 of them fail. Cold backup, you will provision a new server from your backup. That's the recovery that you're interested in. Provision it and then start it. It will run with cold caches, which means you gotta warm it up and then bring it into the live environment. And then warm is somewhere in between. You will have it readily provisioned, maybe running, but it's not served by the load balancer. So you can cycle it in quicker, but it's also a little bit more expensive than just having a cold one, especially when cold means you're running in a cloud and you can just provision a new server. If you're running on your own hardware, then you've got to have that available somewhere. But it can be shared with different environments where you can allocate it to Liferay, recovery, to any other application that you're running. On the cluster side, I still like to discuss this, especially on the DXP side. Are you running active-active, active-passive? Are you running N+1, which would be something like active-active-active passive for however many servers you will actually need. With these clusters, when you run them, there's always cost involved. Not only the servers, but in an enterprise supported environment like Liferay, like the database, like the load balancer, and so on. There's typically something also in licensing and subscription cost. So just be aware that what we cover here is the DevOps aspect. It's not the licensing aspect or the software support maintenance cost. It is just what we need on the technical side. If we say, well, the easiest way is a hot backup is to run 6 cluster machines at the same time, even though you only need 2, yeah, that keeps your business up, but it comes with the extra cost. In this training, I don't care about cost. I care about keeping it running. So that's something that you want to always be aware of. The N+1 cluster, as I've said, is something like an active-active-active passive cluster. N+1, so you'll need 3, you'll add another one, and you can cycle it in, you can easily provision something. Trivial with Docker in the cloud, a little bit harder in your own infrastructure because you've got to prepare it. Already covered the active-passive cluster, you can actually bring up a full disaster recovery site. Now, in my time in a business continuity company, in a business continuity job, we have always taken care of data centers that go dark. There's always got to be a replacement data center where we can fire up all the same infrastructure, maybe almost the same infrastructure, but that was what we ran with back then. In the cloud age, not so much. We can distribute or we can deploy on yet another cloud or in yet another region of the same cloud. If one data center goes down, we still can fire up a second one. That would be our model of an active-passive cluster. An active-active cluster basically means we'll just run more systems than we need anyways, and if one goes away, meh, so be it. An important aspect on the cloud side is to think about proximity, because it's trivial to say, well, my servers are everywhere in the world anyways, but physical proximity is something that you should keep in mind. You can't just deploy everywhere in the world and just assume, well, my cluster just works, but you should actually keep physical proximity in mind. Unfortunately, as fast as computers did become during the last couple of years or tens of years, Moore's Law to the rescue, nothing has been done since Einstein to accelerate light and electricity. And as that's a constant, physical proximity rules in terms of clustering and in terms of being eventually, not only eventually, but being actually consistent in serving your content. And if you keep this proximity in mind, then you can easily use the cloud providers' proximity configurations and typically stay within the same region. You can distribute, yes, but you typically don't do that on the application server level, but you'll do that with a content delivery network, which deliver all of the content quicker from something more close to you. On the cluster side, physical proximity rules. Last but not least, as one of the aspects for clustering is to serve more load, what do you do if you need to serve a lot of load only few times? Let's say you are running a big advertisement campaign at a certain time and you expect a 10-fold load on your systems. Can you cover that with Liferay, with your existing cluster? Or just because twice a year you'll have a high load, you'll just need a humongous cluster. Let's say we have a couple of universities as customers. And guess what happens the day before students got a reply back that yes, they're going to continue? Almost everybody registers on the last day, which means a higher load than usual. Typically nobody registers to say, yes, I'll be back in the next year, but just before the deadline, everybody's coming. So do you need to cater for that day? Or can you auto-scale? Can you scale your cluster up during the days that you have this extra requirement? And yes, you can do that. Just as I said before with other aspects in this DevOps training, adding another cluster to the existing cluster, adding another node to the existing cluster is just adding another node to the existing cluster. In terms of licensing, in terms of subscribing, in terms of support, that's the business side. We don't cover that. So from a DevOps point of view, auto-scaling is just the means of scaling up or firing up another machine, adding another node to the cluster. On the business side, that might be something else. You might have something to do there, to just license something to buy more support for an individual day. But on the DevOps side, be aware, this is available. Contact Liferay Sales if you're running DXP, and they will make you an offer. In DXP Cloud, which is our hosted offering for Liferay DXP, you'll have this implemented already and you can just configure it and you'll be safe with running it, with configuring it. You'll need to scale down. So auto-scaling always means you'll auto-scale up. We need another machine, we'll have too high a load, we'll fire up another machine automatically. And then scale down is not automatic, but you got to go in and scale down manually. Because you know the profile, the load profile that you're currently serving. Quick repetition, auto-scaling works. On the DevOps side, it's just firing up a new node and adding that to the cluster. And on the business side, take care, see. But as I like to say, this is not my problem as a DevOps person.